Should be on now, anytime. Excellent. Good afternoon, everyone. And welcome to this session around environmental and climate data. And thanks for showing up here on this sunny afternoon. Actually, we were hoping it was raining so everyone would flock in, but actually the people still come in anyway, so that's good. My name is Wim Zwijnenburg. I work for PAX and Bellingcat, a contributor to Bellingcat. And today we're going to give you a hands-on workshop on environment and climate data. But before we go there, we'll do a short introduction, so I'll move over to my colleagues next to us.
Sure. Hi, everyone. My name is Ollie Ballinger. I'm a lecturer in geocomputation at the Center for Advanced Spatial Analysis in London, at the University College London. It's a mouthful, didn't come up with it. I also am a contributor and tech fellow at Bellingcat. Wim and I have worked together on sort of environmental investigations, and yeah, over the years we've made use of a variety of different geospatial data sets, everything from remote sensing to other sort of forms of spatial data on the environment. And our idea for this session was basically to have an interactive, more interactive session where we run through a bunch of like practical ways to access and process geospatial environmental data for environmental investigations.
Yeah, a bit of background for my own work. I work for PAX, which is a Dutch peace organization, and basically we start to use environmental data where we're doing research on conflict and pollution and how environmental damage from conflict affects health of people and the environment. And basically we were sort of forced in, because there was a lack of data on environmental issues in conflict zones, and because you can't access there, it has had, for a long time, had low priority, so we had to resort to using open source and spatial information to document the environmental impacts. So here's a couple of works we did in the last couple of months on deforestation in Syria, and we're also doing a project on, together with Center for Information and Resilience, on documenting environmental harm in the war in Ukraine, and we have a couple of reports out, and a couple of more reports coming. And basically what we do is we use data-driven advocacy, so we take the reports and the findings, and we're trying to advocate for mitigating and stopping environmental damage, or ensure that it's being addressed in environmental, in response post-conflicts, and then strengthening the legal protection of the environment around armed conflict. So what you can expect today? So Ollie's going to do a really great introduction into remote sensing. They're launching a new application today on Bellingcat, which you can see later. Then I'm going to do a short introduction on climate and Earth observation data. So really what are portals with information on climate data, where you can access them, country and case studies on environmental issues. And then I'm going to walk you through a couple of open source platforms where Earth observation and remote sensing data can be accessed, and we give you and lastly, we give you some case studies, which we're working on, but we want actually to be more interactive. So we also would be interesting to see if you have something. So in that case, if you throw out something, we just do it live. And you throw in stuff at us, and we're going to look things up for you, and yeah, make sure you get stuff to do. So Ollie, over to you.
Yeah, great. So this is a QR code. If you scan it, if you take a picture with your phone, it'll load a website. The website is a guide that I put together for Bellingcat. It's called Remote Sensing for Open Source Investigations, and I'm gonna run through that quickly. We're gonna do sort of the front matter to that book. So the remote sensing introduction itself. And then we're going to talk a bit about data sources. But before we do that, I assume because you're here, a lot of you are either have worked with this type of data before, have done environmental reporting, are currently working on things, or are interested in particular phenomena or data sets. So is that correct? How many people here have like worked with satellite imagery before? Okay, fantastic. How many of you haven't worked with satellite imagery but are interested in doing environmental investigations and want to learn more about it? Okay, great. That's a That's like an even mix. We've got several options. I mean, we can go quite like technical into, so we're going to show you a variety of no-code platforms, so portals through which you can access data, but the Remote Sensing for Open Source Intelligence Guide uses a platform called Google Earth Engine, which is a freely available software. This is what it looks like. It has a code editor here, and below it has a map, as you would expect on Google Maps. It lets you load in satellite imagery. So in a nutshell, Google stores petabytes of satellite imagery from a variety of different sources on their own servers. And they've developed a platform through which you can analyze that data also on Google servers. One of the issues in widening access to this type of geospatial data is that it's often quite large and quite computationally expensive to run. So this is a free platform that anyone can register and use, and this guide is primarily geared towards leveraging that platform. I'm not paid by Google. I really wish I was. It'd make my life a lot easier. I'm not shilling for them. It genuinely is a very useful platform, and this graph that I put together shows the use of Google Earth Engine in this line in red in scientific research over the past over the past 20 some odd years. It outpaces a lot of more traditional geospatial analysis platforms. So it really is a platform that is used widely for scientific Earth observation, but it also carries immense potential for open source investigations and things that you guys might be interested in. Okay, so I'm going to talk briefly about remote sensing. How many of you were at Micah's talk this morning, Satellite Imagery for Crisis? A few. Okay, good. Actually, not that many of you, so I can just repeat what she said and you won't be too mad. So remote sensing is basically the science of, in sort of the area that we're going to be talking about, observing the Earth from space. There are two broad divisions in the types of sensors that are available to us. We have optical sensors. These are the sensors that you'll probably be most familiar with. So optical satellite imagery, RGB images, the type of stuff that you would see with the naked eye, basically. But there's also a second class of sensor called active sensors. These are radar sensors. So they don't see the Earth by taking pictures of it from space. Rather, they send pulses of radio waves from the satellite, and they measure how much of that return signal reaches the satellite once again. So you can think of this as the way in which a bat sees the Earth, right? It emits a call and it listens to a response. In the process, you lose visual artifacts, things like colors and shadows, but you gain the ability to see through clouds because the radio waves can penetrate clouds, and even image at night. So Micah referenced that this morning. That's sort of how that works, and it unlocks some interesting capabilities that we're going to get into in a bit. So broadly, we have two classes of sensor. We have active and passive sensors. Then one of them, like the main rubric by which we assess the utility of different remote sensing platforms is probably resolution. So there are actually three types of resolution. There's spatial, spectral, and temporal. So spatial resolution is probably the most straightforward, right? It's how sharp the image looks. So if we look here, we've got a sensor that is relatively low resolution. So 1 pixel is 30 meters. So quite fuzzy. You can't really tell what's going on here, right? And this is Landsat 8. This is a publicly available satellite from NASA. Then we've got medium resolution, which is about 10 meters per pixel. This is also publicly available Sentinel-2 data. It's another optical sensor that the European Space Agency runs. You can kind of tell what's going on here. You can probably tell that this is water and that this is sort of urban land cover. And then we've got high resolution. That's generally anything under a meter. The nomenclature here is not actually precise. People kind of use these terms loosely, but that's sort of generally how we talk about these things. And with high resolution imagery, you can see quite a bit of detail. But spatial resolution isn't the only form of resolution. Spectral resolution is also quite important. So different materials reflect light differently, and we can exploit that to distinguish different materials from each other. So the most straightforward example that we can probably think of is distinguishing vegetation from non-vegetation. So this is an image of Gillette Stadium in Boston, where I'm from, and if we look at the fields here, we can see that there's a field in the middle of the stadium and then some training fields on the outside. And to the naked eye, in the visible range of the spectrum, we see the color green, right? And this field looks green, and this field looks green. And if I asked you whether or not the field that the Patriots play on is real grass or fake grass, or if they train on real grass or fake grass, you couldn't tell me that from this optical image, even though it's high resolution. But if we get a lower resolution sensor like Sentinel-2, lower spatial resolution, but greater spectral resolution, we can look at parts of the light spectrum that go beyond the visible and that capture more information about the material. So plants have chlorophyll, plants reflect wavelengths of light in the near-infrared part of the spectrum. Micah touched on this morning. And we can exploit that fact, even though we can't see it with the naked eye, right? This just looks green to us. If we calculate an index based on the, like that part of the spectrum, the near-infrared part of the spectrum, we can see that the fields outside of the stadium show up as bright red, strongly reflect near-infrared, and are thus probably actual real vegetation, but the field in the stadium itself isn't. So we've now distinguished fake grass from real grass using wavelengths of light that we can't see with our eyes. So the sensors that we use, spatial resolution is important, but it's not the most important, depending on the use case that you have at hand. Spectral resolution can also unlock new insights. And then finally, temporal resolution is a factor. How frequently can you get imagery of the same place on Earth? Sentinel-2 has a revisit rate of 5 days, which means that it can image the same point on Earth roughly once a week, slightly more than that. This is a nice visualization ESA have put out. But other closed source or more expensive satellite imagery sources can image the Earth up to 12 times per day. So by launching many satellites at different orbital trajectories, they can achieve much higher revisit rates. So depending on your use case, you probably want to consider these three factors when using satellite imagery. Spatial resolution, how sharp is the image? Spectral resolution, how much of the electromagnetic spectrum are we collecting data on and can we use? And temporal resolution, how frequently do I need new imagery? Are there any questions about any of those three concepts before we move on to looking at different data sources? There never are questions when you ask it like that. Okay, well, so those are three sort of broad metrics by which you can assess what type of satellite imagery might be useful for you in a particular use case. So now I'm just going to run through a couple different categories of remote sensing or a lot of like machine learning applications, which we might get to if we have time, can be used quite straightforwardly with optical imagery. So for example, here I've trained a neural network to identify different types of vehicle using optical imagery. So it can automatically, you feed it a high-res satellite image, and it will automatically identify helicopters, planes, small vehicles, but you could easily train it to identify anything else. And one of the case studies down here, object detection, runs through how to do that. Then the rest of this page on this guide is formatted in a very structured way. It has a description of the type of imagery, some potential applications, and a table that has the name of the sensor, including a link to the platform, the time frame that it covers, the spatial resolution, and the coverage. So what parts of the Earth are covered by it. So here we have a bunch of different sensors. We've got the Landsat satellites and their respective time frames, the Sentinel-2 satellite, and a couple a couple other ones, and you can easily compare which data set would be most useful to your use case. So these are all optical satellites in this table. But as I mentioned before, we've got a whole second class of satellites called synthetic aperture radar satellites. These are the active sensors, the ones that see like bats. And those don't generate optical, data that, they don't generate pictures, basically. So you have to interpret them slightly differently. But this, as you can probably infer, is a radar image of sort of a marine setting. So we've got a port, and we've got some ships, and we've got this. I wonder if anyone has encountered this type of thing before in radar imagery. Yeah. Yeah. So we don't know a priori whether or not that would be like a military radar. Some naval radars are strong enough to interfere. This is not really related to the rest of this presentation, but some ground-based military systems use the same frequency as the satellite, the synthetic aperture radar satellite, and generate interference. And it looks like this. And you can use that to find certain systems like Patriot missiles or S-400s that generate this type of interference. But they're also, this radar satellite is very useful, as we're going to see soon, for detecting things like oil spills on water, but also seeing through clouds and detecting land cover changes as well. We then got nighttime lights, which is satellite imagery taken at night. That's very useful for detecting things that might be not really that visible during the day, but maybe quite bright at night. This is a fun visualization that Wim and I worked on for an article that shows the fall of Mosul to ISIS. So here we have Mosul, then it gets captured by ISIS and the city darkens considerably. Then you can see the front line emerging, pushing towards Mosul, and then it being recaptured by the KRG and brightening again. At the same time, we've got Erbil, which stays bright the whole time. And below we have these bright areas here, which are flaring from oil extraction. So the burning of excess methane from oil extraction. So nighttime lights, particularly useful if you're interested in tracking like oil extraction or petrochemical companies. Then we've got climate and atmospheric data. So this measures the level of different compounds in the air. You've got pollutants like nitrogen dioxide or sulfur dioxide, very harmful to breathe in, common byproducts of combustion. This is an example of a sulfur plant in Mishraq in Syria that was attacked by ISIS and set on fire. And it released a cloud of sulfur that basically spanned to the Arctic Circle, Japan, Libya, and Tanzania simultaneously. So it released a plume of sulfur dioxide that spanned like almost around the world. And you can access this type of data by following these links. Then there are also, oh, yeah. Yeah. Oh man, we could spend all day on this one. I mean, you've got like industrial activity in northern China, right? Coal plants burning coal, heavy industry produces a lot of sulfur dioxide. You've got volcanic activity in parts of Africa, some really active port cities because these big tankers burn really dirty fuel that releases lots of sulfur dioxide. You can actually see shipping lanes if you look faintly right here. Yeah, I'm not going to spend too much time on it, but you can see a lot of industrial activity by virtue of the emissions that they generate. So you can also get data on mineral deposits. We've been talking a lot about South Sudan recently, and if you think about the political economy of a lot of conflicts, mineral deposits are a highly relevant source of income for rebels a lot of the time. I'm speeding up because everyone's looking at me. We've got fires. You can detect fires quite easily from space because they burn very brightly. We actually checked this earlier, but this morning I looked out there and there was a fire somewhere over there, and we found it on firms. So it's quite good at detecting hotspots, and what those hotspots mean depend on the context that you're looking at, but this is a screenshot of fires over Ukraine in the past year. Many people have looked at this, but it very clearly sort of traces the outline of the front line in the war. And then finally, we've got population density estimates. Those are generated in a kind of complicated way that involves merging like administrative statistics with building footprints and stuff like that, but they let you get a rough estimate of the number of people in different areas. So if you need to check like how many people, if you see, for example, like lots of emissions coming from a particular facility, and you want to estimate roughly how many people might be affected by that, this type of data is very useful. Then building footprints, similar use case, right? Gauging exposed populations. Building footprint data sets have recently become widely available, and then administrative boundaries also may be useful for figuring out, like calculating totals of various like pollutants, or if you're calculating the flooded area, you would need to know sort of the spatial extent of the administrative area that you're interested in. And then there's also a data set on georeferenced power plants, and they're disaggregated by type and the amount of energy that they produce. So that was a very quick introduction to all of the different types of data that are hosted on the Earth Engine catalog. They're also available elsewhere than the Earth Engine catalog. And Wim is now going to show you, we're going to have a more hands-on session with some of these data types and show you live how to look at and query a specific type of phenomenon that you might be interested in. And hopefully, if any of you have like questions or a particular use case in mind that you want us to look into live, we can try to do that. We can't guarantee we'll get good results, but yeah, if anyone, yeah, got one over here.
Yes, you to try the ERI5 data set, the reanalysis one, is that available?
On Earth Engine, I think so, yeah. Yeah, it is available.
I'm trying to load that once.
Directly on
Earth Engine, yeah.
You tried to load it on Earth Engine and it didn't work.
It was maybe too heavy for my computer, so.
So that's the great thing about Earth Engine is that it, you can run it from your phone because it's not actually running on your device locally, it's running on Google servers. You're basically submitting a request to run a computation on Google servers, so it's actually completely independent of the computational resources of your own computer, which is how it sort of widens access to that, because as you said, like environmental data, if you've got like minutely or every 15 minutes global observations on things like sulfur dioxide, you can imagine how big that data is. It's gonna melt your computer. So Google have, for some reason, allowed people like us to hog their compute. They're doing something with it. I don't know what, but they're okay. Sorry, Wim, take it away.
Yeah, I'm just trying to get the adapter to connect. I'm not sure if someone from. It doesn't seem to be working.
Oh, here we go.
Oh. Weird. I think I had the same problem that you had before when it doesn't switch to your main screen.
Damn. Bear with us. Well, we can't see the screen.
Yeah, it's not the screen here.
In the meantime, we can do the Q&A. Do people have... So again, we've had people who've worked with satellite imagery before. Are there particular use cases that people are interested in, or any questions on anything that we just ran through? Yeah.
Extension.
Ah. Yeah.
5 years or 10 years?
Yeah, so the question was, can you get the fire data historically? Yes, the firm's data is historical and it runs from the year 2000 to the present. And it's about, yeah, so, and you can also look at burned areas, not just active fires, but you could definitely do sort of historical comparisons as well, yeah. Oh, you've got loads of questions. Do you want to do some questions now, or do you want to? Okay. Yeah, that's good. Yeah.
Okay, just a quick one. So is there a simple way to determine what kind of plantations on the satellite imagery? Like, I would like to differentiate between soy plantation or palm oil plantation or pristine forest, blah, blah, blah.
That's a fantastic segue into one of the platforms that we're going to look at in a second, which lets you choose between different types of like vegetative land cover. There's Global Forest Watch, right? Yeah, so we'll show you in a minute how to do that. Do we have one more before we move on to?
Yes, I was wondering if you can see historical data of climate migration. But I mean both at the same time, the people who maybe moved and also the satellite weather data which might be relevant, combined in one image historically.
Seeing like where people move to.
Yeah, affected by massive climate change impacts.
Yeah, I mean that's a tough one. For that type of question, you often sort of have to break down the question further into like what is a like sort of geophysical manifestation of that I can see from a satellite, right? So nighttime lights, for example, very often used as a proxy for like population density. It correlates pretty closely to that type of thing. So you can watch cities grow over time, establishing like causality between a city growing and climate change would be hard to do, and probably outside the scope of what a newsroom or even like a university would be able to do. But you can certainly watch cities grow over time by how bright they are at night. I think we'll pass it over to him to do some more interactive stuff now. But thanks for your questions.
No, these are the good questions, and it's one of the reasons why we did this workshop. Like, is to ping back and forth with those kind of what are the requests from the journalistic community, and what's available in terms of remote sensing data, and where we can find each other in the middle, where things are actually able to visualize things, but there are also stuff that really takes like a long time to investigate, where you need like on the ground research as well and ground truthing. So, but I think what we want to do here is just to visualize, to show you some of the portals where, suppose you're a journalist, you're working on a story in a particular country, where do you get the data? And how can you visualize some of the stuff that you want to work on? So today I'm just going to walk you through 4 main portals. There are new ones coming up every day. It's hard to keep up with what's developing, but I think those are really, really useful. Some of them have already been discussed in other sessions for different reasons, but I think it's still good to quickly dive in a couple of those. And that will be Sentinel Hub, which is heavily supported by the European Union, but also it's a private company, but they're doing great work. And I'm showing the EO browser, the World Research Institute, which have several data portals on specific topics. And today I'm just going to dive into the Global Forest Watch one, EarthMap, which is developed by the FAO. It has like also linked with Google Engine, but they have all kind of preset models loaded into it, which is really helpful to dive into. And I'm going to steal this phrase from you, Micah, to use it as a canary in a coal mine, because like you have to start that one. You can look some things up, like some general patterns, and you can always dive into more specifics. And NASA Earth Observatory, which is also a really useful tool to use. So kicking off here. So suppose you want to look something up on, and this is done by the World Bank, which has a great portal, and you want to look up like background information on a country which hit the news. So for example, so you go to a website, let's take Afghanistan for no particular reason. So it has a really good overview where you can immediately get like all the relevant data on what's happening on climate developments, and it goes really into like detail on what's happening there in terms of like temperature change, precipitation, and then you can always dive a bit more into the background of the country itself. So if you're a journalist and you're looking into a background of the climate data into a country, this is like a really go-to point. It has a lot of data which is built on sets which is shared with the World Bank. And it's just an opportunity for you just like to browse through the website. But I just want to show that like if you do background research, this is like really, really relevant and really helpful webpage. The next one up would be the Climate Watch database. So here, again, for example, we take the World Bank. Climate Watch has like all the data available on emissions, the goals. There's also, I think, data in there as well. In this case, it's maybe less relevant with the Taliban now, I don't think they're very much interested in achieving climate goals, but so take, for example, another one like Austria, which probably has like more documentation, and if you can find all these documentations to relevant websites, what kind of agreements they signed up to. I think in particular, if you want to look into accountability issues or what countries have pledged, those kind of things are very helpful just to give you background. So all these international organizations signed up to all kind of agreements where they promise to share data. There are international organizations doing the research themselves. I think that's, as a journalist, it's very helpful. Well, suppose you want to look into, and that's another helpful tool I use a lot in research on conflict-affected countries, you want to have more information on country profiles, like on environmental stuff. I think the Convention on Biological Diversity has really good country profiles, which gives you a really good overview immediately with all the nitty-gritty details on environmental stuff in countries itself. So just as a backup to the... if you want to write a report and you want to understand what environmental issues in the country are, I think CBD has really good information. Like you can pick a country and again, we take Argentina, they have to report everything. My Spanish is non-existent, but suppose you speak Spanish, like and it can easily stuff that can be translated. I use it a lot as well with Google and then translate stuff from Arabic or just to English. And it gives you a sort of good sense for, hey, this is the environmental issues in a country. So that's more the climate portal and climate data. There are many more opportunities there. I don't go into them all, but I just want to flag those two because I think it has credible data and reliable data. Next up, I promise to go into Sentinel Hub, and this is just a general overview. This is Sentinel Hub here. I took the EO browser, which is semi-free. There's a free version, but you have limited access to imagery. There is also access for journalists and researchers for free, and you can also apply to kind of grants on EO browser. I want you now, and there's also, of course, a paid version, but I think for people in the room here, you should be able to get access to it. So I want to take an example here, looking at South Sudan. South Sudan is a country we've been looking at for our work on looking into like what the impacts are in flooding, if flooding is getting more extreme. And in particular, we were looking at like what are the risks of flooding to oil facilities. Here, for example, you go to the location, it gives you all kinds of teams. So they have all kinds of special thematic teams of Earth observation data, both radar, so optical and radar data. In this case, we're going to check, we use floods and droughts. It looks here for Sentinel-2. So we look here, and I know for this, for example, I take you to this location. This is at Baluch in Upper Nile. So here you see all these oil exploitation sites where they dig up oil, and next to these sites, you see all these kind of drilling pits where they put the wastewater. And the reason we looked into this because our partners from South Sudan were concerned over flooding and how the floods and the oil spills get into the water, and then people already, of course, have to flee the flood, so there's a big humanitarian situation, but we're also concerned because many people here have a lot of cattle, and cattle are dying. People were concerned about health effects from the oil getting into water sources, so we want to see, okay, can we just see how the floods are affecting the oil fields? So here I just quickly visualize it. This is natural colors. This is like how you would see it normally. And the floods were happening in January. So we go to January this year. And then you can see here, this is normal color. You see all these, this is water which has flooded a couple of these locations. And what we did, we manually mapped all the oil pits here and trying to see if they were flooded. But there's also other kind of options. So here, this is the non-difference water index, which gives you the reflection, picks up like what's water and what's soil. So in this case, you can see it, and it's also, this one is a tricky one because the floods in South Sudan are not like, a couple of meters high floods. In some locations there are, but sometimes it's also like 30 centimeters or less, so it's always not super strong. But it gives you an idea like where the water reaches. And what's nice here, you can also make like a time lapse. So for example, you want to see if what's happening, and then you can select, like I want to see all the imagery from the flooding seasons, take September. You're trying to get as less clouds as possible. let's take a week because a day it takes long. And it collects all the imagery over a certain time and then creates a small movie or animation where you can see, and I can speed it up for time's sake. So here you see the flooding used to be worse before and then sort of slowly disappears over time until it runs until January. So it gives you a good indication, okay, so there is flooding. We use high resolution imagery to identify the sites. We could use this one to demonstrate the flooding. Then there's always good to double check things. So for example, here I looked at the World Bank, if they have anything on flooding. Here the South Sudan has, the UNOSET had done some really good research on, now I lost the location where I had, oh here. So they have like flood monitoring in South Sudan. So this is like AI generated flood modeling. So you can see already here compared with the other one. So this is where the UNEP did a flooding model. They made a flooding model using artificial sort of intelligence. And I think it was based on radar imagery, if I'm correct. But you can see that it's missing things. So it's always good to, and this is the location we were just looking at. So it's here. And you can see there was less flooding in this oil field in March than we saw earlier. And you can also download this map immediately. But it's a good visualization of flooding. And let's take another example here on wildfires. So in Spain, there was a wildfire season was starting earlier this year. So suppose you want to look into wildfires. Again, you use EO browser. They have a special wildfire script as well. Here I think I used a normal, this is the normal vegetation, how it normally looks like. I already sort of preset it because just for time's sake, but there was here we use the shortwave infrared, which gives a nice, both shows the vegetation, but also shows the fire itself from the infrared from the fire. So this was before the fire, and then 5 days later, you can see the area is totally burned. You can still see some fire smoldering here. And suppose you want to check that. In this case, I looked up with the Copernicus. It's also a map used by European Union, which shows all the fire data, and in particular in the season at the moment, and climate change induced fires are likely increasing. So this is a very helpful tool where you can you should play around with the website. I'm not going to talk about it in details, but here you see the same location where they gave out a warning, and there were detected fires here using what Ollie mentioned earlier, the VIR script, and it sort of maps this here. And there's actually also a possibility here to visualize burned areas, but I think this is not going back. Yeah, so here it automatically calculates the burned area with MODIS. So you can also get like an overview of how much was burned. These are just two applications, looking at flooding and looking at fires. We use it for many other issues, oil spills as well. But moving on now to data sources. So I mentioned the World Research Institute. I think also I don't have a GIS background. All this stuff I learned by just trying this thing, trying these tools, talking with people who actually did study this stuff. There's a great online community where people are helping each other, where experts are there. And so it helps you to understand also like how to access data, how to read data, what it actually mean that you're looking at. And this was interesting for me. So back in 2017, we were looking at this, and I wanted to look at so I used this. So basically, the World Research Institute have a bunch of portals. We already discussed Climate Watch a little bit. I'm now going to show you Global Forest Watch. So this is part of my work is looking at the environmental impacts of the conflict in Syria. So I was looking back at this back then. It's like, hey, this is interesting. There's a lot of deforestation going on in Syria. And what it does, you can just go by country. You can click on a country. You can click on a region, and it ask you to analyze it, and then you get a complete overview, in this case from Latakia, and it shows you how much forest deforestation took place between in the last 20 years. So clearly you see here, after 2011, there was a massive increase of forest loss. This is based on a preset database from Hansen, which uses Landsat imagery. But for us, which is relatively, it functions, but it's a relatively crude model. So we use this database to identify where the main areas are. You can actually, well, I'm not going to do that now, but it's helpful to get an indication, and then we developed our own script with our in-house GIS expert, and we did it for the whole country, and we looked at all the deforestation in the conflict, which was linked mostly to more people needing firewood because fuel prices were getting up. There were a lot of IDPs. There was deliberate burning of forests, so it's quite intense. So there's that. So Global Forest Watch is very helpful. I already mentioned Earth Map. So again, you should play around with this. It's just a website where, based on Google Earth Engine, where you can look at all kind of issues. Here, look at Syria. You want to look at is there anything interesting here on Syria on extinction? Well, this is probably not working. Athletics fire, so it gives you a burnt area overview in Syria over the last couple of years. And the frequency, there's one on, I think even go by country, so you can see when a lot of fires were happening. This is more interesting because this is mostly related to stop burning. But still, suppose you want to look into areas here, we can see there's more fires going on during conflict areas. We can easily see all the burnt areas in this. Again, this is a big website. There's a lot of data sets here, but I just want you to show what kind of stuff you can look into. So I got Earth Map, and then I want to go to Earth Observatory from NASA, Worldview, which has a lot of different things as well. Just look at the website. I'll give you a quick example here, looking at dust storms. If it loads, yeah. So this is like last year, there were major dust storms in Iraq, which was into the news. And here it was happening in August. It has really large, low resolution data, but it's very helpful. You can easily visualize the increase of dust storms, and you can actually make a movie if you want. But I just take the slider here, and you can see, I know this area here, it's close to Nasiriyah, where there's a desert where naturally dust storms are occurring, but you can see here, so this area here. Now pay close attention, and then you see things getting increasing. So this is like a very bad area. We saw the pictures from Baghdad coming out. So it's a really helpful tool to quickly show where the impact is of all these dust storms happening in the Middle East. And you can, if you want, you can make a nice movie with it as well here. This is one example of, and the last one is what actually was kind of interesting we were looking into today. Fears that were just mentioned, and it also shows potentially, we think, the different environmental regulations. So here we see, this is Russia, this is Kaliningrad, here is Estonia. So apparently European regulations likely prevent farmers from stop burning, which is not present in Russia. So you see a lot of fires here from post-harvest burning going on here. Again, already discussed earlier. Also looking at the time. So the main idea was just to quickly show you where the portals are, where to find the information. I'm just putting up all the linkages to all these websites. So if you want to take a picture here, feel free to use it. And just want to come back now to if there are any questions in particular for what we just discussed today. I see a lot of phones coming up.
Yeah, it's hard to distinguish the phones from the hands. Yeah.
I have a question about the radar. I know we've discussed this before, but do you think that they'll actually change how radar systems work for some of the Patriot missiles now because you have openly announced?
The question was on radar interference. These ground-based missile defense systems, primarily Patriot missiles that interfere with publicly available Sentinel-1 radar imagery. They have. The European Space Agency has updated the way in which they pre-process radar imagery recently, which is kind of annoying for that. But yeah, they have, which is sad. We got one in the back, yeah.
This is actually more of a statement rather than a question. I'm here on behalf of Lisa. We're running right now.
Hi, thank you. running a grant right now for any journalists interested in developing services that benefit the journalism industry. So yeah, please come find me after if you're interested. Sorry, shameless plug.
Sorry, can you give your name and your organization again? I think people there didn't hear it.
Sorry, my name is Ben from European Space Agency. Thanks.
I didn't mean what I said about the European Space Agency. I love you guys. Anyone else?
Thanks. Sonia, I had quite a specific question just in terms of, is there a particular data set that you would recommend that kind of optimizes fairly granular thermal imaging, also with relatively kind of high time frequency?
So Planet Scope data, which is sort of freemium. You can access it for free, but downloading it is a bit harder. It doesn't have thermal, but it has near infrared, which does let you see, it does let you gain some information on heat. You'd really be looking for something like shortwave infrared to look at like really thermal stuff. Like the Landsat program is probably your best bet as far as I know, and that's pretty bad resolution, 30 meters per pixel. There's a new company launching next year in 2024 called Albedo, who claim they're going to do 30 centimeter thermal imaging from space, which that would be extremely impressive, but it would definitely not be free, and also seems like pretty bold claims. Yeah. Yeah, we got a question up front.
Thank you. Just to retake the question a colleague did in the beginning of the session of which one of these tools can be good to differentiate the types of vegetation, whether you have like a soy field or a pristine vegetation. Which one of these can help us look at it?
Well, I think that's the kind of question. I mean, it's possible, but we have to go deep into using NDVI. So you have to look at specific reflection of specific plants, and you have to set certain parameters in your analysis, which you can do automatically, I think, which you have to do like manually in the assessment. But
so I think also Global Forest Watch have crop maps. Also, some governments provide crop maps. There's also the Food and Agricultural Organization publish, I think, estimates of the spatial extent of different crops, but I think those are estimates. I'm forgetting off top what the name of that data set is, but I think it's, it has an acronym, but the FAO would be the place to look for that type of data. Yep.
I'm doing a story coming out in a couple of weeks that is about, well, part of it concerns some people who had their homes burned by their government, and they say that it happened on one side of a line, and the government says it happened on the other side of the line. Would you be able to see those fires in temporal resolution if they're fairly small structures like huts?
Yeah, I mean, pass the mic up and to your left, because the mic has worked on the mic. No, I'm kidding. But yeah, that's a very typical use case for that type of imagery. Obviously, you can't guarantee anything, but I would certainly look into that. It would be NASA FIRMS, FIRMS. They do both active fires and burned areas. And as I said earlier, it spans, I think, from 2000 onwards, and it's like daily. Twice it, wow. Yeah, nice, yeah.
So the firms typically is about twice a day. Maybe on average for the week, it's more like 10 times. And it's usually sometime maybe during the night and sometime during the day. It lists the time in GMT. And it depends on where you are in the world. I think if you're kind of in the extreme north and the extreme south, it might be less.
Yeah. Great. Anyone else? Oh yeah.
Sure.
Oh yeah.
So back to that. So I have two questions here. Back to the first question is that the differentiation between like soy and palm oil. I think my idea is that there must be some formula that you can use to analyze the NDVI satellite imagery to get the different types. Is that correct?
Yeah, yeah. So even per plant, like tomatoes or soy or whatever. So you have to know the specific parameters of the plant, and then you can distinguish them.
All right, and that can be done through the GE, right? The Google Earth Engine.
Yeah. So there's like the easy way of doing this and the hard way of doing this. The easy way, like I would, if you're looking for the spatial extent of different crops, that is something that governments and organizations...
No, not government. So like we want to detect the changes. So not based on the government data.
No, so they will do geospatial analysis, like the U.S. government or the Food and Agricultural Organization of the UN.
Yeah, but we're talking that countries that don't do that.
So the Food and Agricultural Organization does global crop extent maps, if I'm not mistaken. If you wanted to do it the hard way yourself, it would involve looking at like the growing season of a particular crop, loading in imagery, like NDVI imagery for that period, and then looking at whether or not this crop, like the vegetation in a particular field, corresponds to the growing season of a particular crop. So you can do that, but it's a lot more complicated to do, and I would be 1000% sure that there isn't a crop map for that crop that already exists, because loads of organizations, not just governments, do this type of analysis. So only do it yourself if you absolutely have to, but if you have to, it can be done.
Yeah, because we are trying to detect like illegal plantation deep in the forest. So those data is not available from the government.
So you could certainly distinguish between like forest and like a soybean, because those are very different structures. You could look at planet data as well, especially for deforestation. If you do a time lapse in a particular area, you can see the forest being clear cut and agriculture replaced.
We do use GFW. The second question is about access to high resolution satellite imagery. You have any advice for journalists or newsrooms? It is very tough to get below like sub 1 meter imagery, and they are like expensive. So what are some of the ways that you are able to assess them?
So a couple of options here. So for example, there are, if you engage with, for example, Planet, they will offer free imagery to a journalist, also high resolution, which is for Planet is like 0.5 from SkySat. There are also options if you have a smaller budget, for example, through EO browser, you can also buy for a Maxar or Airbus imagery for like really low prices. And there was a new one, which I haven't used yet, but it's out now, which was used. Skywatch, yeah. So you can buy it per square kilometer, I think is the minimum one, or even smaller. So you pay like like a couple of $10, $20 for something you look into. I mean, you can also do the same through EO browser, which has all these data things as well, and it's relatively easy. And I use it all the time if I don't have access to the other sources. And there's also sometimes there's really good updated imagery on, for example, on Google Earth. Depending on the country, but like sometimes they have even up to 2023. They have on Google Earth Pro, the desktop version, they have really recent data, but it really depends on the country.
Okay, I think we're out of time, unfortunately. But if anyone has burning questions about environmental data, corner Wim and I at some point. We're around for the next day or so. But thank you all for coming. It's been really fun.
An hour is way too short.
I was going to say, great presentation.
Oh, thank you. Cheers.
Everybody's going to follow you.